In this tutorial, we'll be covering the Excel basics. First, again, let's find Excel in the search bar. And there it is, and we can see by right-clicking that we could pin it to the taskbar. But we can also search through the Programs menu, again, to find Microsoft Office and Excel, and we right-click and pin it to the Start menu. And hit Escape, and there we see Excel 2013, and let's open it. Alright, so we'll select a blank workbook and go to the File menu to open a file on our computer, back to my same directory, and we'll choose a text file from the File Type menu, not an Excel file, but we'll work on importing a text file, and we see that there's one in that folder. We'll open it, and we have a pop-up menu of options for importing a text file. Ours is a delimited text file, that is to say there's a character that separates each column. And we go to Next, and we see that if we select the tab delimiter, which is the default, as this file is delimited by, then each of those number, color, mass yolks gets split out into separate columns, and then we finish by that importation step. Okay, so we've got a file to work with, but first, remember, saving files. Now this is a text file, so now we'd like to save it as a Excel file, and again we have many options here, which we're not going to cover all of today. That's now saved as an Excel format file. All right. Now, if we go to the File menu and click Options, then we'll see that a pop-up window gives us some add-ins. I want you to go manage your add-ins, ensuring that you have the Analysis Tool Pack and the Solver add-in selected. We won't necessarily use those today, but we will want them as the weeks go by. So let's look at our Home menu on the ribbon. We see that we have the usual font formatting tools as other Office documents. Let's look at an Insert here again. Now the main thing we'll be concerned with today is inserting charts. And then if we look at the Data menu, we see there again are those add-ins that we just created. Those will come in handy. But let's go back home now. First, we're going to learn how to do a little autofill. So if we select a cell, that's cell D11, and we click the little square that's present in the bottom right corner of that cell and drag down, then we're going to fill all of those cells with whatever was in that original. We'll do the same here in column A. It can be a little tricky to grab that square sometimes. So you want to avoid moving your data. When we finally get it, there we go. We'll drag down. Oh, and we see that we filled that column with 10s. Now that's not what we wanted. So if we want to autofill a series, we'll collect a couple of cells and then drag. And then we'll see that whatever trend was present in that series that we selected originally will be present in the rest of those cells. So we filled that out to 16. And this happens to be for eggs that I collected from my chickens. So I collected their color, mass, and the number of yolks. It's kind of fun that we see this huge egg had it was a double yolk egg. What are we going to do with all this stuff? Well, I want to play with manipulating data. And we'll insert a column by right-clicking and selecting Insert. And this should be in mass in terms of grams. And then we can see here that we can change that to ounces if we wanted to in that function window, the function bar. So you can enter data into a cell either in the cell itself or in the function bar. We'll go over to column D1 and we'll also enter weight in ounces here. All right, so how do we convert grams to ounces. So we type equals to create a formula that will act on a set of cells. So what's the conversion for grams to ounces? Well, we'll type C2 for the cell that we want to act on. So equal C2 is going to act on cell C2, asterisk for times, and then we'll write 28.35, which is the conversion factor. And we see that we get 2,200 ounces approximately. Now, we can use relative or absolute references to those cells. So by putting a dollar sign after this, before the C, we tell it that we're only going to be working in column C. And if we put a dollar sign behind the 2, then we tell it we're actually only going to be copying that cell. And so then there's no updating of the cells for each of the cells in column C. But so that's a absolute reference. We back out and we just want to do a relative reference, that is to say, each cell will be updated as we move down the column. Then we want to get rid of those dollar signs and only use the letters and numbers of the cell. So C2 is a relative reference, relative cell reference versus absolute cell references. You want to be careful with using absolute cell references, and we can usually stick with relative cell references unless there's a need. So we can see here that we filled in that whole column with D with our repeating our formula in each new cell, so that we've converted C mass in grams to D weight in ounces. Now we can also use a formula functions. So if we hit or go down to cell D19 and entered equal, and then we can see that a whole series of functions, automatic functions, appear for us. We're going to choose from that menu standard deviation. So we're going to compute the standard deviation of these masses, and we can enter the cell number. So equation type, function type, open parentheses, enter the cell numbers separated by a colon, close parentheses, and that gives us our standard deviation. We can also compute the average. So again, function type, after an equal sign, open parentheses, and we can also click and drag. We don't have to enter the cell range manually. Be sure you close your parentheses before you hit enter. And then we'll see we have an average or median mass, the mean mass, and the standard deviation. I don't like that this has 2 decimal places, so I'll go to format cells by selecting those cells, and the category we'll select number, so that we can change the number of decimal places to 0 in this case. I'll leave it up to you to figure out what our significant figure should be, but you want to be careful about that and adjust your formatting appropriately. Now we can also make the cells a little wider, the columns a little wider, so that we can see the titles that we've given them. And I'll highlight that first column and click bold to make those column headings more noticeable. And also you'll notice that you can select a border type, and I'll choose a heavy bottom border, thick bottom border, right, to set apart our column headings from our data. And I'll put a big box and bold and color. By clicking the paint bucket, we can color our important data, which are statistics of the eggs that we just computed. Next, we'll turn to our data analysis add-on. And we're not going to use this tool to fullest extent today, but just as an example to see how you can generate a set of descriptive statistics. So we'll click that and say OK, and then we'll have to define an input range, and it's very convenient, as it will be with graphing, to use this tool to define what your input range is. You can enter it manually if you want. And we're going to tell it to create a new worksheet, or those are also called plies, and we'll call it stats. And we're going to just report the confidence level for the mean. We'll say OK, and we'll see that a new worksheet has been opened that just has the confidence, 95% confidence interval for that value. And that's pretty weak. So let's go back and choose again to make our descriptive statistics. And we'll choose instead we'll make a new sheet. Yes, and we got to choose the summary statistics for that range. And now we see in that stats 1, now we have a whole slew of statistical information, including mean, standard errors, standard deviation, etc. Now, while we're here, we can see so we see all of our values here: median, mode, standard deviation. We can make a comparison with what we've observed already. Standard deviation for the mass in grams, we can adjust. So we'll select that to insert a new cell. So we go back and say, right click and say insert, and shift the cells down. So now we have a new cell in our little table of simple statistics. And this will be the standard deviation for grams. So we start a new formula, equals standard deviation, open parentheses, and now we'll select those gram masses. Oops, yeah, I should correct that to say grams. And we'll see now that the standard deviation for grams is 6, but maybe we want to see some more significant figures. So we can go to Format Cells, right-click Format Cells, choose Number, choose 1 decimal place, 5.6, matches the standard deviation that we got from our statistics data analysis package now. Let's note that we can double-click on the name of that new ply and give it a different name. We can always rename those. So better stats and lame stats, I'll call those two. We can also click this button to get a new sheet whenever we like. Not that we need one right now. We can always save. Save your work. Use logical naming system for your file systems. Remember that Excel doesn't do versioning either, so if you want to keep the original version, you have to save with a new name. Okay, let's switch to a different topic now. This is opening a new spreadsheet that I called 305 week 3 concentration assay. It's a set of protein concentrations and absorbances measured in a colorimetric protein concentration assay, something standard for all of you when you get to biochemistry. And then so we have the standards on the left, but then on the right we have a series of analyte samples. It's very easy for us to select those data, go to Insert and Chart, and we can see a whole array of charts, and then we get previews of what those charts will look like. A bunch of scatter plots. The best one for us is to just use a plain scatter plot. And let's go to Quick Layout up in the top left to realize that we can go choose a default pattern that gives us a variety of different options. The main thing we'd like to see is that all of our axes are labeled, etc. So we'll choose that top left option. And now we see that we have an axis title for the x-axis, the independent variable, and we'll put concentrations in milligrams per milliliter. So that is that column A, the x values, and then on the for our dependent variable, we'll put the absorbance. So this is again a standard curve where we have a measurement of absorbance for a set of standards. Oh yeah, we can give it a title name. Let's call it some old concentration standard curve. We can choose the series. We can select data should we feel like it. We're not going to cover that today, but you can also define what columns are being chosen. But right now we just selected those data. And if we right click on one of the points, we can immediately drop a trend line that is a linear regression. You see that you have a bunch of options in your format trend line. We can do exponential fits, linear fits, logarithmic. We'll talk about more sophisticated fitting another time. For now, let's be sure that we display the equation on the chart. That's useful for us, and display the R-squared value. And now we see that in addition to our linear regression, we have the equation that we're going to need to determine the concentration of our analyte samples. Now, I like to emphasize that it's important for you to decide every aspect of a particular plot. Do you need those grid lines? Yes or no? It's your decision. Do you need this legend of the series and the fit? Yes or no? It's your decision. But now let's take a moment to use that equation to compute our concentration. So we set up a new formula in a cell corresponding to sample 1, that is in cell F2. So equals the absorbance value, 0.237, minus, so that's our y, minus, so we brought our 0.193 over. We'll ignore this for now. 0.193, we're gonna collect those in parentheses, divided by 0.0011. And that will give us a computed concentration in milligrams per milliliter of sample 1. And if we would like to copy that same formula well, we can define it as a cell using absolute or relative cell references, of course, as we've done before. And if we use an absolute reference like I showed you before, we're going to copy that same calculation into all cells, which is obviously not what we want. So let's go back and say instead use a relative cell reference, cell F2. And then when we copy the formula into the other cells, it will update for each individual new cell F3, 4, and 5. We can format those, go back and choosing number as our category, changing the decimal places as befits your particular needs for propagation of errors and significant figures. Now we can also use the formula bar as we saw before to compute statistics on a set of data. So there's our average, and we can, in G7 here, we'll call that the mean. And then we'll, in G8, we'll write standard deviation and go back to H8 to say equals for a new formula, standard deviation. If you want to find out what all those different standard deviation formulas are, I'll let you research that on your own. For our purposes, it doesn't matter today. Just realizing that we can use those canned formulas to quickly compute some simple statistics. So we have a mean and standard deviation now in milligrams per milliliter from our standard curve. Now let's return to our graph. As I said before, everything must be decided upon by the user. So what's wrong with this graph? To my mind, we need some ticks on the axes. So we'll go to format axis. We have you see all these options that we can choose. We don't really want any of those right now, but eventually we'll be interested in error bars. We'll talk about that in another tutorial. Let's go over here to our format axis window. We can see that we can select tick marks, and major ticks don't belong inside, they belong outside. And we can go back and do the same for the x-axis, choosing major ticks pointing outside. I usually don't think minor ticks are necessary. It really depends on the situation. In this case, not terribly important. We can collapse that back down and think about what other decisions we might want to make about this graph. Color. We have a line here. We can format the trend line, And you see that you have a variety of options, not just for defining the trend, but also for defining what the colors are and the line types. So we'll choose black. Don't choose a color unless there's a reason to. We can do the same by clicking on the data point itself for the data. So we'll go to marker now and choose a black border for the marker, but we also need to fill it properly. So we go back to format, markers, scroll down, and to find our marker options, fill. There we go. So we'll fill that also with black. So we have a black line and black markers with no need for any color. The color denotes nothing in this graph. So you make careful choices as opposed to allowing Excel to make your defaults. Yes, and we can see that I forgot to say what here, that I'd like, why would you draw that as a dashed line? Is there a reason for that? Go back to your formatting, your trend line, and choose not only the solid line, but also the dash type, no dash. That looks better, but it's a little fat, so you can go to the width of that line and dial it back down to something that's a little bit more reasonable looking. And now we have a reasonable looking graph with choices that we have made. Oh, you can always go back and correct typos. But we've made all of the decisions about this graph, and it looks wonderful.